Special types of functions and the implied domain. So the type of functions that we can have, there's 4 different types. The one-to-one, where one x value maps onto one y value. Many-to-one, so more than one x maps onto one y value. One-to-many, one x maps onto more than one y. And many-to-many, more than one x maps onto more than one y. That should be the word more. To determine if a function is one-to-one, we perform a horizontal line test, and that's all it is. Vertical line test for the relation and horizontal line test for one-to-one. Line must cross anywhere on the graph at exactly one point. If a domain is not stated, then we refer to it as an implied domain and take the maximum possible for our rule. Example, S, xy such that y equals x squared has the implied maximal domain R. We just assume that it's reals. But T, which x such that y is the square root of x, has the implied maximum domain from 0 to infinity, because square root of x starts at the 0. Example 1, state the domain, sketch the graph, and find the corresponding range of each of the following. So for this one here, for the domain, it's whatever is under the square root, 2x minus 5, okay, and that would have to be greater than equal to 0. So when we solve this, we've got 2x is greater than equal to 5, so x has to be greater than equal to 5 on 2. So it's a square root sign, so I know that it will start at 5 on 2. There's my y, there's my x. It cannot be any that is going to start right there, and it will look something like that. And the range, I'll write the range here. The range of this graph here will be from 0 to infinity. So I'll write it as 0 to infinity like that. With this one here, we know what type of graph this is. It has an asymptote at 5 on 2, so 2.5. So I'll just change the color and draw my asymptote in. And that's at x equals 5 on 2. So let me just extend this. This becomes x. There's my y. The other asymptote, of course, is right there in the x-axis at y equals to 0. And in green, I will draw the graph. So this one will look like this. And this one will look like this. Okay. Go back to my blue. Doesn't really matter where it crosses there. I don't need to find that to work out the range. The range that this one can take is, again, remember all the y values, so it can take everything except 0. So I'm going to write it as the reals except the 0. And that's your 6D questions.